prediction of reverse bias leakage current in aluminum gallium nitride and gallium nitride stack HEMT devices using machine learning and assembling modeling.
What happened?
Good evening, everyone. I'm Aishwarya Tomar from BITS Pilani campus, and today I will be presenting our work titled Prediction of Reverse Bias Leakage Current in AlGaN-GaN HEM devices using machine learning and ensemble modeling. This work has been carried out under the guidance of Professor Apurva Chakraborty and Professor Kanchan Mana. The core motivation behind this work The core motivation behind this work is to use machine learning as a tool to predict reverse leakage current, which is a critical parameter in GaN-based power devices. Here is a quick overview of today's presentation. We'll begin with the motivation and the dataset overview. Then we'll ponder on the question that why machine learning for GaN HEMs, followed by the models explored in this work. Then we will compare our model with the other models. So why machine learning for GaN HEMs? Traditionally, device-based modeling used physics-based equations, which are quite complex and require computational time. For device modeling, we use softwares like TCAD, which require a deep understanding of semiconductor physics, and it also takes much of our computation time. However, machine learning, if we have a proper data collection from the experimental values, if we have that, then machine learning can directly learn from these experimental data points. Once trained, machine learning models are very fast to run, and they do not need physics-based equations. So this is the dataset overview. We have collected the experimental IV measurements from AlGaN-GaN based HEM devices. The data was collected at different temperatures. The voltage range was from -15 volts to +2 volts. The input features for this were the bias voltages, the temperature, and the aluminum composition was fixed at x equals to 0.3. And our target variable was the current density. So from this graph, we can observe that from -15 to -5 volts, we can observe the linear trends. From -5 to 0 volts, we observe the parabolic behavior, and from 0 to 2 volts, we observe the exponential rise. One thing more, that we have converted this data set from wide format to long format for compatibility with machine learning models. We have first started with our baseline model, that is the decision tree regressor. This decision tree regressor actually splits the data into regions and then fits a constant in each. This model gives us a very high R-squared score, that is of about 0.99, which means that the data is quite fit and it trains well. But what are the limitations of this baseline model? From the graph, we can observe that it can't interpolate smoothly between points. It creates jumps or steppy predictions. The current curves are smooth in real devices. If we are expecting from device modeling, we will expect smooth IV curves. So this baseline model was not suited for our results. So why actually these decision trees struggle in device modeling? The trees split data into fixed intervals or boxes. Within each box output, we get a flat output value, which leads to non-smooth, steppy predictions. And moreover, this baseline model do not have any understanding of continuity between nearby voltages or temperatures. So then, what we did, for improving the stability, we moved to random forest regressor. It actually combines many decision trees, and it gives a mean value of those decision trees. This is used to basically reduce the overfitting and noise. This random forest is better than a single tree in generalizing patterns. Features were the same. For input, we have taken voltage, temperature, bias, and for output, we were observing the output current. It was trained on 70% of data and tested on 30%. From the graph, we can observe that it was smooth. It helped smooth out on extreme predictions, but still there were blocky transitions between the voltage and the temperature levels. We got a very high good score of R-squared score and a very low error. We have taken basically 100 trees to smooth out the local noise. Despite numerical strength, random forest lacks the ability to model the continuous device behavior. So then what we did, we used another model. It was learning from mistakes, that is the XGBoost regressor. So basically what it does, it builds the trees sequentially. Each tree corrects error from the previous one. First one tree is made, then from its residual error, another tree is made. So it can model complex and nonlinear relationships. It achieved strong overall fit, it shows, but there were some limitations. It showed overfitting at some temperatures. For example, as we can observe around 140 degrees Celsius, it deviates from 125 to 150 degrees Celsius trend. XGBoost captures nonlinearity well, but memorizes training behavior at times instead of generalizing. So from this, what I can conclude is that high test accuracy doesn't always mean good physical modeling. Then we moved forward to a light GBM regressor, which is fast and efficient. It basically works on histogram-based algorithms. All the previous models uses tree-based modeling, but this one uses leaf-wise growth. It allows fast and deep splits. These were the results. We got the MAE, RMSE, and R-square value. We observed that the R-square value was 0.85, lower than expected. Despite fast training, light GBM shows reduced accuracy and generalization in this application. Then the next model was stacking regressor. So in this, it basically learned from multiple models. Here we have combined diverse models. That is the linear regression, the XGBoost, the light GBM, and the CatBoost. Then combining the input from these previous models, we make it through a meta model. For meta model, we are using the XGBoost regressor, and it learns how to combine their predictions. It takes advantage of different learning styles, so it improves generalization and stability in predictions. So by letting a model learn from other models, we reduce both bias and variance in the final output. For results, we have 361 training samples and 155 testing samples. Then the final one. The final model which we have used in our work was the hybrid model, where the accuracy meets generalization. It combines the 3 gradient boosting models, and it also used Optuna. Optuna was basically used for hyperparameter tuning, and it was also used for optimizing the ensemble weights. One more factor was introduced in this hybrid model was these engineered factors. Since we know the IV curves in device modeling are not linear, they are always non-linear, they are logarithmic in nature. So we have introduced engineered features like voltage into temperature, voltage square into temperature, and other logarithmic relations. So we have achieved the lowest prediction error and the best curve interpolation across the entire temperature range. So our hybrid model results were the... Sir, it's going to be over. Okay. So it was the best in class, our hybrid model results. These were the results. So basically, we have compared all of the models which we have used in a work, and the hybrid model was the best in class. And this was the performance comparison from other machine learning-based works done previously. These were the references used. Thank you.
Thank you, RISC-V, for insightful and engaging talk.
Thank you, sir.
Questions from
Thank you for the nice talk here. One fundamental question is, you have only shown the comparison of how different algorithms, of course, these are all classical machine learning, not deep learning. So classical machine learning models, whichever you have used, you have compared with your experimental data set, right?
Yes, sir.
So finally, suppose you are claiming that the hybrid model is the best one. Then what do we do with that best model? Because from VLSI perspective, I will be looking into, okay, you have done material characterization,
Yes,
and then I would like to make a chip out of it. That is my end goal. I am not interested to see the comparison of the different models.
Sir, maybe I couldn't have got your question well, but I'm going to answer for the best of my knowledge.
The idea is how do we apply these models
Yes, sir.
for making a real chip? That's my question.
So for getting a real chip, before going for fabrication, in fabrication, we generally use our device physics knowledge and some trial and error results.
Correct.
Okay. So before that, if we go for simulations, we generally use TCAD softwares like Silvaco TCAD, Centaurus Synopsys. So there we have an algorithm, we have a code for developing that particular design.
Yeah.
Usually it takes much of a time and we have to learn complex equations. If from that simulated data and from the experimental results, we get certain amount of data sets, the current simulated values and all that. If we train a model to learn on that particular data, and if it can predict the future unknown values for it, then we will have a help in the future for designing some kind of chip.
No, the question is for example, if you want to design one, let us say a small inverter only.
Yes, sir.
Okay, very simple inverter.
Yes, sir.
In that case, we need to have a continuous equation which can be coded in Verilog AMS.
Yes, sir.
Or else you can use a library.
Yes.
Like 1T nanometer, 45 nanometer technology node. Okay, so this library you can put it in Cadence to make a circuit. Makes sense, right?
Yes.
But that Verilog code is a set of equations.
Yes, sir.
BSIM model is a set of equations.
Yes, sir.
What you are telling is a set of data.
Yes, sir.
There is a difference between the two.
So the set of data, if I'm saying this work has been done on experimental, prior to this work I have done work in which I have used machine learning on the simulated results.
Correct.
So where in that work, basically I have inputted the data set from the simulated results.
Okay.
And these simulated results were derived from the closed derivation equations of the semiconductor physics for that particular device we are dealing with. So these data sets are already, they are correct, they are valid. And this machine learning basically learns from how these trends, how the current responds to the voltage. That's why I was telling that in the baseline model, the current couldn't relate with the model. There, it just goes in a very linear way. Our hybrid model, because we have introduced that engineered features, the non-linear aspects, that is, if we are squaring voltage square into temperature, let's say, the complex equations, it deals with this model, learns from the complex equations in a backwise algorithm that it learns from the mistakes, and then we divide the data set training and testing. It trains on our actual data. Then for the 30% we can go for another.
Okay, just in the interest of the time, why didn't you try transformers? Like we are using GPTs everywhere, no? Generative pre-trained transformers, right?
Yes,
Chat GPT. So this, why don't you use transformers? That's kind of, transformer algorithm will train any non-linearity much better than what you have done.
So
Look into it.
so it's a good insight, and okay, I'll try in future.
We have one more question we can take actually. Otherwise, thank you.
Thank you. Thank you.
So our last speaker, Nilesh Gupta. So he will be presenting on machine learning based insight into the stability of halide perovskites.
The pointer. You can use that pointer. Will it highlight the portion? Is it there? You can start. Anything? Hello everyone. Good afternoon. I am Dr. Nilesh from Faculty of Engineering, Electronics and Communication Department, Chandigarh University, Uttar Pradesh campus. It's a new campus. So my topic is machine learning based insight into the stability of halide peroxides. So here is the brief outline of my presentation. Introduction, challenges of doing stability analysis of any kind of 2D material, precisely halide peroxides, role of machine learning, data set preparation and feature engineering in order to get the insights of getting stability of the materials, advantage of using ML and comparison with DFT, and last, conclusion and future work. So basically, halide peroxides are class of crystalline materials, which is actually in the form of ABX3, where A are alkali metal or alkaline earth metals, and B are cations like transition metals, and X primarily here halides, fluorine, chlorine, and bromine, etc. Halide peroxide basically attracts attention as promising material as they have high electrical conductivity, good catalyst performance, strong semiconductor behavior also, a high light absorption and adjustable band gaps, long carrier diffusion length, and ideal for basically light emitting diode and solar cells. Also find interest in cathode materials for the battery applications sometimes. So challenges with doing stability analysis. First, let us know what is stability in our aspect. Stability is actually key to understand the thermodynamic behavior of peroxide or any other 2D materials, helping to predict whether the crystal structure remain intact or decompose in other phases. So problem with doing all this calculation is it needs a lot of calculation cost, computation resources. So if you do with the formation energy, you need to find out what is the amount of formation energy. It should be negative in order to get the thermodynamical, stability of the material. Further, phonon dispersion is also there, which is basically deals with density functional perturbation theory, where we actually check the dynamic stability of a material. Then in both cases, whether it's formation energy or DFT-based phonon dispersion, we need to find out negative formation energy and known imaginary phonons actually in the materials. So further, DFT actually gives you the most accurate result if you find out the accurate exchange correlation function. But the issues with the DFT are it actually demands for the high computational resource, especially for the larger and complex material. And second thing, it is also sensitive to the exchange correlation function that you need to opt before starting the calculation. But specialty of machine learning is you can predict a DFT-based output using machine learning in a faster way, can explore large compositional space quickly, reduce the need of expensive DFT calculations, and you can also learn the complex pattern not easily captured by DFT. So before we start anything, okay. So we actually collected the data, number of data from a DFT database, primarily from material projects, which is available online. So I just collected number of materials which belongs to peroxide family. Primarily here, single peroxides also there and double peroxide also there. At the end, it's a target variable where you can see it is stable or not. One for stable material, and 0 is for non-stable, unstable material. So it is available for my material project. You can access that. So now it is required to have a domain knowledge to apply the machine learning. So we actually fit the features based on the literature, based on the intuition, based on our own expertise. So we just choose the features like tolerance factor. The right-hand side, first I'm telling, these are geometrical factor. These are geometrical features. So tolerance factor, which is also defined there, octahedral factor, and other are A side mismatch factor for double peroxide and B side mismatch factor. Other we can also choose lowest unoccupied molecular orbital energy, HOMO. Similarly, ZR is there, Younger pseudopotential radius, oxidation states of the compounds. So these are basically features based on our literature review, based on our expertise and intuition. So we all put together in this format. So you can see the first column is the material or compounds, and the last column are the target. 1010, it's a classification-based problem. We are going to predict whether the material would be stable or not. And in between, we put the feature of the individual compounds, like oxidation state of compound A. So if you consider first one, the compound COAgF3. So A is for CO, B is for Ag, and F3 is X. So we just put it all the features over here, and we then apply random forest classifier. So we just take the 80-20 ratio. 80 is for training purpose and 20 just for doing predictions. Further, we also reduce some features because of feature may also having some redundant knowledge. So in order to avoid the redundancy, we also apply RFE, recursive feature elimination. So just after the application, you can see over here, yes, okay. So you can see that accuracy was achieved around 83%, but if I apply RFE also, just reducing the features, after that, the accuracy enhances up to 85%. So you can see this, this confusion matrix where it says 139 materials are correctly predicted as unstable, and 17 materials are predicted as stable whether they were unstable. Similarly, the bottom one here, 141 materials are stable and they are correctly predicted, and 11 material were stable actually, but they were predicted as unstable. So it's a false prediction. This diagonal one values are false prediction. These are true prediction. We can also trace what the features which are actually relevant to the stability prediction. So you can see here, tolerance factor T is the most relevant factor having the highest probability, and other are EA, that is electron affinity of compound A. Mu is the correlation factor, and other features are also involved, which are the top 15 features, which actually we applied RFE followed by RFC. So in order to validate our computation using machine learning, I also applied Gaussian process regression, where you can also see before applying RFE in any respective machine learning algorithm, we achieve 83%. So it's a cross validation. And second thing, just after recursive feature elimination, we reduce some features and only include top 15 features. We get the accuracy around 85% in both the machine learning models. The top feature also, most are the relevant. You can also compare both these two. So idea is to have how we can predict the materials, whether they are stable or not based on their features. And we can also apply these particular models. Let's say if you have this kind of matrix, and the first column having new compound which is actually not known yet, and last column is not present here. So you can apply that particular model to the new composition which are actually not being explored yet, and you can predict the stability of new compound. So at conclusion point, ML provides basically fast and scalable alternative of DFT. Even it cannot replace, because for the database we need to have DFT calculation, of course, and it actually enables high throughput screening of halide peroxide in our case, identify the key descriptors, as I have shown the feature importance over there, and similarly it reduces the computational cost while maintaining the reasonable accuracy also. So future work, what we are actually looking to, we just looking to integrate more relevant advanced machine learning models. Also to apply this particular model, as I told earlier, to find out unexplored peroxide materials, and their further properties can be also explored, like band gap, using some regression model. So last point is we need to verify also some predictions. Like if you have predicted 1,000 new materials, let's do 10 to 20 calculation based on DFT in order to validate those. So this will be a future work in our work to validate at least randomly selected 10, 20 materials so that our results could be acceptable for the future work. So these are my collaborators also who work for this paper. Thank you so much. So I'm also looking for questions, if any.
What is the source of data set?
It's a material project. It is available online. You can access using either Google Colab or there is also similar version is there. This is available on materials project. You can access using Google Colab.
According to you, sir, this is verified data.
Sorry?
Verified data.
Based on, to the best of my knowledge, it's verified. Whatever available there. You can also take the literature. I mean, you can also take the data from various published paper. It is up to you. If you're not, if you're not sure that these data are validated, you can also take data from the literature, from the papers. But it is helpful actually to have thousands of data from the materials project. There are also other websites also. I cannot ensure others' work. Sorry, sir? I didn't get that.
Okay, another one issue, like I think sir is from materials, like he can also tell, like mostly we have seen that if you are doing DFT calculations now, in general it is almost, I mean, very, very difficult at least. I shouldn't say impossible.
In terms
very
of
difficult to match it with the actual experiments.
Yes, sir, definitely.
So how are you getting a tally of that?
There will be some difference between practical output and DFT predictor output, but you are actually getting something which is close to the relevant output. Like you are predicting some new materials which have some band gap like 1.1. If you go for the practical, when you really test in practical, you will get 1.3 something. So, but in practice, you are actually getting that this particular material belongs to semiconductor or close to that value.
Okay.
There will be. That's why I mentioned here also. You need to opt a precise exchange correlation function also. Nowadays, we also going for hybrid functional HSE and GW for getting accurate results. Earlier, it was LD and GG exchange correlation functional, which was actually underestimate the result many times. It's being found.
So you are telling about AutoML and GNN is generative neural networks. What is it? GNN?
Graph neural network.
Okay, understood.
So I'm just saying that other machine learning model can be implemented. First thing. Second thing, you can predict 1,000 new material at a. I mean, it's a simple code. If you're ready with the code, relying on the DFT database, you can predict your result within 10 minutes. Maybe it is 1,000 new results, maybe 10,000, maybe 100. But in order to ensure all these results, you need to check randomly, like 10 or 20 results, because you are actually you are just reducing the computational cost. But in order to validate, let's say 20 or 30 calculation you do randomly and check the result whether the ML prediction are validated by DFT or not. I mean, the only way in order to reduce the computational cost.
Okay, I have one question.
Yes, sir, please.
So you showed many materials, actually 2D, 3D materials.
They all are 2D materials and belong to this family, peroxides, yes.
Do you have any experience with 3D materials?
Not yet, but certainly we can explore.
So why 2D materials actually?
Sir, in order to, yes, from my perspective, in order, as we are, I'm not VLSI expert, but as we are advancing the technology, we are actually looking to miniaturize the technology. For example, flexible electronics is also there, new peroxide, solar materials are also coming in future. So it attracts, I was being attracted because of number of reasons.
So most of them are.
Also, when I go for 3D materials, the materials, the number of atoms in a unit cell will be larger, and DFT calculation will take, more computational resources. So it is also one of the reasons, because we are lagging in terms of resources many times. Thank you so much.
Thank you very much for your. Okay. Apologies. Actually, there is one more speaker. So the Pranav Mishra, he will be presenting on
170 download it. No, no, this one. No, no, we have already. We need to download. Okay.
Hello, good afternoon, everyone. Today I'm going to present on investigation of vertical FBFET for logic and static memory application. I'm Pranav Mishra from IIT Patna, and my co-authors are Subir Das and Professor Dr. Pramod Kumar Tiwari. So this will be the outline for my presentation. I will start with motivation, then introduction, literature review, proposed device structure and its working principle, variation in transfer characteristic with device parameters, memory characteristics, application as 1T SRAM cell, logic in memory characteristics, and then I will conclude. So motivation behind this work is as the IoT, AI, deep learning are rapidly increasing. So it increases the demand of computing power as well as high memory. But von Neumann architecture has a bottleneck, which is it has a logic and computation capability at a different place and memory at a different place. So we need to bring the memory to the computational unit and then put it back at the memory again. So this causes some latency. So we need high density memory as well as logic in memory capability, which can truly unlock the potential of emerging technologies. So density of traditional SRAM cell can only be reduced by reducing the number of components in it. And logic, and in recent times, it has been shown that logic in memory architectures reduces latency by combining logic and memory blocks. So basically memory blocks has logic capabilities inbuilt in it. In recent research papers, it has been shown that feedback FETs shows a highly steep switching characteristic, high on and off ratio, current ratio, and strong memory window. So gate all around FBFETs has already been shown that they can used for universal logic gate design and reconfigurable logic in memory. But the problem with gate all around is like the size cannot be reduced further, and problems in fabrication. So the comes vertical feedback transistors, which can be reduced further, and it can be, the fabrication is easier with this. So in this, my research work, I have shown electrical and memory characteristics of vertical FBFET and applications in memory and logic application. And I have used Silvaco Atlas for all the device as well as mixed mode simulation. So these were the papers which I took reference from. So basically vertical feedback FET is demonstrated by SS Katta already, and I have shown the applications of it. So this is the device structure. Basically, there are two channels with a different doping. So P plus, N plus, P plus. So basically N plus and P plus both combines the complete channel, and then N plus. So these were the parameters used for to design this FBFET. So basically it works on positive feedback principle. So there is a drain channel 1, channel 2, channel so So in equilibrium state, there cannot be any conduction because holes at drain side will feel a potential barrier from channel 1, and similarly electrons at source will feel a potential barrier from channel 2. So when we apply the drain voltage to it, it will lower the potential from drain side, but still the holes will feel the barrier, and electrons will feel barrier from channel 2 side, and still there is no conduction. So as soon as we start to apply gate voltages, the holes will feel less barrier, and they will start moving towards channel 1, which will bring, and similarly the electrons from the source side will feel less barrier, and they will start to move to channel 2. And that will make this potential barrier further lower, and at one point there will be a flat surface and there will be a high current, and both electrons and holes are involved in the conduction. So this will result in a sharp switching characteristic as well as high on current. So this is the transfer characteristic. So variation of transfer characteristics with different device parameters. So we have varied the channel length and doping concentration as device parameters. So as we increase the channel length, the barrier width will be increased, and we will need more gate potential to make a positive feedback, to infuse the positive feedback in it. And similarly, in doping concentration, higher doping concentration means higher potential barrier, and since it will need higher gate voltage. And in case of drain voltage, we have checked with different drain voltage. So basically, if the drain voltage is less, so there won't be any alignment, which will make this positive feedback wrong. So memory characteristics. So basically, because in case of in feedback FET, there is a potential well. So in switching after on, then if we are tracing back and giving reverse voltage through gate voltage, then it won't follow the same path because the charges will remain trapped in the well. So because of which there is a hysteresis in its transfer characteristic, it won't follow the same forward and backward path. So forward switching path will be called as latch up, and the reverse path is called latch down voltage, and difference between them is basically the memory window. So with different drain voltages, we have checked the width of the memory window width. So as the more alignment will be there in positive feedback, the memory there will be more conduction, and there will be more memory window in it. So we have tried to implement this feature, this hysteresis feature of this as a 1T SRAM cell. So basically, state 1 and state 0 will be decided by the presence and absence of excess charge carrier in the off state. So basically, if we write 1, there will be charges present into the channel, and if there is write 0, then there won't be any any charges remain in the channel. So in hold state, potential barrier is high enough to inhibit any carrier flow. So we have selected this write voltage VBL here, and in this graph we have done the write 1 hold, and then read 1, and write 0 hold and read 0. And this is the band diagram which is in hold conditions. So basically, SRAM means like there is no degradation in current even after 800 seconds. So we have applied the read voltage for around 800 seconds, and there was no change in the current. And similarly, we have done the read after 500 seconds, and still we got the same value. So retention and states were maintained. Then one important thing is like we need to check the disturbance analysis, because we are using VBL for read and write. So we have applied 2 cross 2 1T SRAM array, and in that we have checked, we have tried to apply read and write potential, and we checked the states whether they are corrupted or not. And also we have continuously read it for 50 cycles, and we still got the same value. Next comes logic in memory with vertical fits. So basically we cleverly put a register with this gate and made it a NOT gate. So retention time and non-destructive reading characteristic all will be remain same as of the device itself. Similarly, we have put two gates FBFETs in parallel, and we implemented the NAND gate through it, and we have done all the 0, 0, 0, 1, 1, 1, and all those results. So with this, I'll conclude my presentation. So from this presentation, I can say that vertical feedback FETs can be used in memory, logic, as well as wave shaping applications. And 1T SRAM shell shows non-destructive readout characteristic and retention time of more than 500 seconds. And in future work, it can be used to implement ternary FBFETs by using one P-type FBFET and one N-type FBFET, as well as SCMIT trigger applications. So this can have application in binary neural networks as well as stateful logic implementation. So I'm really grateful for Professor Dr. Gopi Krishna. So he helped me in infrastructural support as well as guiding me. These are my references. Thank you.
Thank you, Pranav, for your informative talk on FBFET, vertical FBFET. So now we have some questions.
Why do you call it static RAM and not dynamic RAM?
Because dynamic RAM needs refresh rate.
Then this will need refresh.
No.
It's not, very large.
Sorry?
It's only some seconds, right?
It's 500 seconds. So basically that number is different. In case of dynamic RAM, you need refresh it's in 10 seconds or maybe. Or maybe.
It depends on application. If let's say I want to store data for 10 days, then I need to refresh your memory.
Okay.
It's not a static RAM. It's a dynamic RAM.
And that is the reason why 1T you are telling. DRAM is also 1T.
Yeah, I saw both the applications, and I was like, I have tried to implement it that DRAM first with that. So I was not getting the same current in for 500, 800 seconds. I need my current levels were going down, and I was not able to read till this much time. And I have seen this application which was done with 1T SRAM only, and they show similar characteristics experimentally as well. So that is why I took reference from there.
I'm not suggesting, again, as Sir has also pointed out, we are not suggesting that anything wrong with your work. The only thing is why haven't you have the 1T SRAM, not why not 1T DRAM?
My reason was just key. Yes. So and there I saw the clear difference that it was the refresh time was less.
It depends on the application.
Okay.
For an application such as CPU where you need to clock it for some nanoseconds, then it's fine. You can call it as a in general, you cannot classify this as SRAM.
Okay, understood. Yeah.
Future work, you have
Yes.
ternary FBFET can be implemented using a FBFET, and how you have any knowledge how you will do that?
Basically, I will just implement a inverter with this.
How?
So, like PMOS and NMOS, and the combined
Which
gate.
inverter? Ternary has three different inverters.
Three states. So basically, we will tune it in such a manner that the basically this graph is like for PFET it's left side, and for NFET it's right side, and then there is in reverse path there is a common area which will be the part of hysteresis. At that point there will be a third state. So this will be current direct path. I have done that. I didn't put it here, but it was I did.
No problem. I am just asking that there are three
So
different.
there is basically one is right and left. So then if in reverse path it is coming down here and that is going down there. So there will be a point where both area will collide. So at that point we have to tune these two for that purpose, and there it will give three states. Yes. So basically, your one will be at negative voltage and one will be at positive voltage. So if the zero case will be when there is a short circuit and you are tuned at a point where both are in reverse path and both are on. So that will be your zero. But at one point when one is on, it will be a positive voltage that if you will consider that as a switch, so it will give you a plus of PFET, the drain voltage of PFET, and in next case it will give you a negative voltage of NFET. So you have three voltage states. Basically, you will get positive, negative, and at zero. Thank you.
So please collect the presentation certificates.
Yeah, the speakers can come and collect their certificate as well as they can come for the course.
Now, Suji agrees. Next, Dr. Nilesh Gupta. So next, Aishwarya Tomo. Yeah, sure, please.
You can do.
Yeah. Manesh Prabha.
Hello.
You can do it. But he has never.
नहीं नहीं स्विच ऑन सीगा हेलो
माइक मिलेगा हमें और चल तो जाएगा वैसे
lose weight. Come on, you can do it. But he... 100 million people exercise daily. 4 million
इसे अभी ऑन है तो भी आ रहा है।
हाँ अभी जैसे ऑन दिखा रहा है,
ठीक है।
ये ऑन दिख रहा है तो ऑन है।
My team to please give a formal welcome to our guests. And I request each of our judges to please accept our welcome gesture.
Good afternoon, ladies and gentlemen. It is my absolute honor and privilege to welcome you all to Circuit Penure VDAT 2025, a premier platform where brilliant mind blends technology and entrepreneurship to shape solutions that matters. Before we dive into this exciting journey of discovery, let me extend a warm and heartfelt welcome to our distinguished guests. Mr. Harinder Singh, Chairman of Gavin Engineering Services Private Limited. Mr. Vipul Duggal, founder of Prestige Energy Solution Private Limited, Panchkula. Mr. Prateek Sikka, Senior Group Manager, ST Microelectronics. Dr. Akash Sodhi, General Manager, IHFC, IIT Delhi. We are truly grateful for your time and presence. Our teams have worked passionately to turn the abstract ideas into solid prototypes. So without further delay, let's begin with our team presentations. Our first team is Numino Technologies, led by Dr. Srinivas Daulatabad. You want to present from here or you will be presenting from here?
Yeah, I'd like to be close to the screen.
You would like to be close to the screen. Shimak, mics.
So we are able to participate. First half he'll be speaking. Next half I'll be speaking.
What is your team number?
So team number is
First, Srinivas. First. First one. It's first one.
I'm not sure.
Okay, so when you will be starting, you give your introduction. Like what's your name?
Take it.
It's not-
It's first one.
No.
No.
105. This is your PDF.
So now when we this ये दिखेगा माउस का
माउस को तो यहाँ पे दिखेगा
वहाँ पे दिखेगा ना यहाँ पे दिखेगा वहाँ पे
This is PPT or PDF?
Yes, PPT. PDF for PDF. PDF में PPT control देना Windows देना है
PDF.
PDF control से print आता है should I mail you PDF?
Sir, this is team RTL ranges. Should we start presenting?
प्रिंट होता है कंट्रोल एल दबाने से प्रिंट होता है हम ये करते हैं हमेशा
Hello, am I audible?
चलेगा नहीं क्या?
यहाँ पे ये हो रहा है मैं पीपीटी भेज दूँगा 2 मिनट लगेगा भेज दो
फिर फायदा क्यों सब समझ लेने का?
आप इसे प्रिंट कर दियो प्रिंट एज PDF चला दो सेव
मैंने कुछ नहीं किया ऐसा नहीं तो भेजो So we can start the next one.
Yeah, you can start with offline.
Online.
So the team number 3, that is RTL ranges. Are you connected? Hello?
Yes, sir. Yes, ma'am. We are connected.
So can we start? Go ahead with your presentation first.
Yes, ma'am.
So yes, you can please share your screen and can go ahead with the presentation. You can start.
Yes, ma'am. Okay. Good afternoon, everyone. We are team RTL ranges. So the problem statement was to design and implement a RISC-V based FFT processor applications. This is what we are doing. So first we have designed the RISC-V processor, that is the 5-stage pipeline processor. Then we have converted the processor into a basic system on chip using the SPI communication protocol. Then we are designing an 8-point decimation in time 50 as a co-processor. Yes. Okay. Yes, yes, ma'am. We are sharing the screen. Is it visible, ma'am? Yes, sir. So, sir, our problem statement was to design and implement a RISC-V based FFT coprocessor for DSP applications, for embedded applications. So the first thing we have designed a 5-stage pipeline RISC-V processor. Then we have converted this processor into into a basic SoC using SPI communication protocol. Then we have designed an 8-point decimation and time fast Fourier transform as the coprocessor, which is also acting as the hardware accelerator. Then we have implemented a branch prediction unit to mitigate the control hazards. This is the overall block diagram of the SoC. As we can see, this is completely based on the RISC-V instruction set architecture that was released by University of UC Berkeley, California in 2015. So first there is a 5-stage pipelining as usual. Then there's a hardware architecture, that is instruction memory and data memory is separate. Then there's a load store architecture, that because load in five stages, that is the fetch unit, decode unit, execute unit, memory access, and write back. In the fetch unit, we have a multiplex that chooses between the PC, that is the program counter, and PC plus 4, that is a program, that is the address of the next instruction, or the address that is coming from the execute stage, that is the branch instruction, which will be PC plus immediate value of the branch instruction. So the main important task of the MUX is to select between PC plus immediate or PC plus 4, and then this is given as an input to the instruction memory, and from the instruction memory the instruction is fetched into the IF/ID register, and from here we are taking the instruction to the decode unit, where there is a control control unit here. The control unit mainly has main decoder and an ALU decoder. Now the main job of the main decoder is to further differentiate the instructions R type, I type, S type, L type based on the instructions architecture. This is primarily based on opcode, whereas in the ALU decoder, we have implemented that in the R type instruction, there will be multiple instructions, just add instruction, subtract instruction, multiply instruction. Based on the func3 and func7 values, we have further differentiated this. Now, the sign extension is mainly used to convert the 12-bit immediate value, which is the standard in RISC-V ISA, to 32-bit value, because the processor itself is a 32-bit design processor. Now the registers are used to store the value and also to give the value. Now coming to the execute unit, we have an ALU. The ALU consists of two parts, that is the normal arithmetic unit, and then there's a floating point arithmetic unit for both the operations possible, and the instruction will decide whether the operation that needs to be performed is a floating point operation or a normal arithmetic operation. Now, the result will now go to the data map. Either will carry forward to the MUX in the write back unit, or suppose if the entered instruction will load instruction from the data memory, it will go to the MUX, and the result will go to the register. Or register, that is ALU result will either go to the register. Suppose if it was a load instruction in the instruction memory, then the data from the data memory will go to the register. Now we'll go to the implementation of the hazard unit. Now, as we can see, there is a data dependence. This is the first instruction, this is the second instruction. In the second instruction, the X1, we can see that the first instruction is not yet completed its completed the write back stage, but we need the result in the second instruction. So we are implementing a hazard unit. Now, how this hazard unit works is interaction with the ALU is depicted here. For example, the hazard unit will send the signals forward A and forward B. So the MUX, this is entirely in the execute stage within the ALU. That is, MUX will get the source register RS1. That is the data from the RS1, data from which is coming from the execute stage. For example, look here, the execute stage. From here, the data will be sent to the next instruction because we need the data of the X1. So this data can come from the execute stage or from memory stage of the previous instructions, and this data will be given to the ALU. Whereas there is similarly a MUX is used, that is source register RS2. data coming from the execute and data coming from the memory state. The same working for both of them, but there is a catch in the RS2. The catch is we can also have the immediate value. Now another mux is used to take the data and the immediate value, and this data is given to the ALU, and the data from the mux1, data from the mux2 are the inputs to the ALU, and the result will now go to the memory cycle. This is the entire hazard unit interaction with the ALU and is completely based on multiplexers and control signals that we are generating. Okay, this is the RISC-V assembly code for the factorial, and this is the hexadecimal code. As we can see, 5 minus 1, 4, and 4 into 5, 20. Similarly, the pattern follows and it will become 1, and finally we're getting the answer 120. This is after 22 clock cycles. Now, this is the overall RTL schematic of the RISC-V processor. Similarly, this is for the floating point unit. We are using pi r square, that is calculating the area of the circle. As we can see, 3.14, that is the pi value, this is the radius value, and here we are calculating the r square and then pi r square. This is the overall floating point unit. Now, coming to the SPI protocol. Now, this SPI protocol is acting as a bridge between the processor, that is acting as the master, whereas the slave, 7 segment, is acting as the slave. Now, from the instruction memory, suppose I invoke store instruction, and it will go to the data memory. The data from the data memory will now go to the SPI protocol, that is 8-bit data. CPOL equal to 0, C5 is equal to 0. That is, SPI will sample data only on the rising edge of the clock, and on the MOSI line, it will send it to the 7 segment, which is acting as a slave. Now, how will the processor come to know that the SPI has finished communicating with the slave? That is, when after communicating, SPI flag, that is the SPI finish flag, is raised, which will give the which will feed the one value 1 to the register 30 in the instruction decode part, that is the register bank, to the main RISC-V code. This is the overall working of the SPI protocol and how it is interacting with the slave as well as the master, that is the processor. Okay, now in this we can see that A is actually being displayed on the 7 segment using this SPI communication protocol. My processor is acting as the master, whereas SPI communication protocol is helping us to transmit to the slave, that is the 7 segment. Okay, now coming to the 8-point decimation in time fast Fourier transform. As we know, the Cooley-Tukey algorithm, the butterfly diagram for the 8-point DIT50 is this. This is acting as a co-processor. That is how we'll explain how the processor will interact with this co-processor. It's also acting as a hardware accelerator as well. This is the overall butterfly diagram for the 8-point DIT-F50. Now, this is the overall microarchitecture of the DIT-F50. This is the input. This is coming from the data memory, and here stage 0 computations will take place. And here these are the intermediate registers, and similarly stage 0, stage 1, stage 2 computations will be there, and then we'll get the output. This will take place in 8 clock cycles, 8 clock cycles here, 8 here, to total after that 56 clock cycles. This will be working independent of the processor. That is, I can do any operations within the main processor. This will not disturb the flow of the main processor.
Umair, you have 2 more minutes to go.
Yes, yes. This is the audio 15 minutes.
Now the main part is from the audio file we are converting the 8-point F50 time domain signals, and the same signals are fed to the main processor, and these are the output we have obtained from the MATLAB. Next, the main mechanism is how the main processor is coordinating with the co-processor. For this we have used a 2 flag register, the R1 and R2. The R1 indicates that it need to start, F50 need to start the operation, and R2 flag indicates that F50 has done its operation, and it indicating that the results are ready, and the results are ready for the next computations. Next, the main beauty of our processor and co-processor is both are running in the parallel. For example, here we can see the F50 is F50 also running, and in the meantime the co-processor also computing the co-processor is also running. Next, these are the inputs we have given to our main coprocessor, and these are the outputs which we have processed from the FFT and given and stored back to the main memory of the processor. And from this output we can perform any operations. Next, this is the software versus hardware error plot. We are getting this much error plot.
Given the increasing influence of the RISC-V, so we have derived the RISC-V. Now, coming to the branch prediction, we are using the finite rate machine using the Yes. So using the simulation of the 5 factorial using the BPU will take us 12 clock cycles only compared to the normal. Now coming to the utilization part, the top RISC-V processor is using 26,000 LUTs and 6,000 slice registers and 689 muxes. The main responsibility is the FFT. FFT is actually consuming 20,000 LUTs. Now, coming to the power consumption, it is very low power consumption. That is just 108 milliwatt. That is 0.108 watt. And the majority component is the static power. The maximum clock frequency that we have got is 48 megahertz.
The main thing is why our processor is market fit. First of all, for the open source RISC-V design, and next the modularity in the design, we can extend our co-processor up to the 64 point or anything we need to open source application, as well as our design is open source, and the main beauty is we are parallel processing, means the co-processor and processor running independently.
Your time is over, please.
Okay, ma'am. Thank you. Any questions, ma'am?
Yes, now the forum is open for questions based on this. So anybody from the audience, judges, if any questions are there? I have a question. What is the novelty you're offering on this RISC-V platform? This is a simple FPGA implementation, but from innovation point of view, what is the innovation you're offering in this?
Ma'am, first we are designing the co-processor, that is the 8-point decimation in time. In the DIT FFT, we are taking the floating point operations. And this is how it is interacting with the main processor as well. How the main processor and the co-processor are communicating is itself an innovation. And they are communicating parallelly, ma'am. So suppose my FFT is running independently. Now I say FFT will take 56 to 60 clock cycles. That is actually minimum. Now I can't halt my processor till 60 clock cycles. So I can run many other operations using my main operations, such as add instruction, sub instruction. This is running independently of the main
co-processor architecture or co-processor implementation is nothing new. It's not a new concept. So what is the innovation we are talking about here in this?
8-point DIT FFT, ma'am, actually. Mainly 8-point decimation in time.
Okay.
Because we are dividing it into stage 0, stage 1 and stage 2 computations, and we are achieving it in 20,000 LUTs, ma'am. That's the important.
Okay, fine. Fine, Umair. Thank you so much for being part of Circuitpreneur. Thank you. We'll shortly announce the results, so be connected. Thank you so much.
Okay.
And you can stop sharing. Thank you.
Okay.
So our next team is Team LeploCare, led by Monish Bugata.
A warm evening to all. So myself, Monish Bogata, and pre-final undergrad from Andhra Pradesh AP IIIT Nusvidu. So I am here to pitch my pitch deck regarding the medical device, LaproCare. So which is an indigenous RISC-V processor-based device to cure the diabetic neuropathy and the leprosy disease. So I would like to thank my professor who guided me. So he is Vinod Babu Pusluri. So coming to the contents, we have the problem statement, solution, and designing details, and novelty, benefits, market analysis, and the competitive landscape, and resource mobilization plan, and the summary regarding that. So coming to the problem statement quickly, so diabetes is the one of the largest disease growing in India and the world also. So this is the statement not given by me. So many researchers or the doctors and the ministers or the governments also still focused on diabetes. Okay, so the problem statement, quickly what we are addressing is that the peripheral neuropathy caused by diabetes. So it is a situation where the human loses the sensation and rather it leads to the amputations of the feet. So this is the problem statement what we are going to address. Coming to the solution, we are developing a slipper for that situation. So not only for the diabetes, we are addressing the leprosy also. So this slipper monitors the pressure, so where the people can't in that situation. So this is the thing, this is the visualization of the product that has been made in the prototype level, and it is presented over the Digital India RISC-V Symposium at IIT Madras. So this is the thing, you can able to see that animation and the position of the leg and the actual product. So this is the thing. Coming to the block diagram, there is a power supply and the sensing layer where we can place the sensors to get the monitor the pressure values, and there is a RISC-V processor to process everything, and there is 2 buffers, one for local and one for online, and there is a cloud to communicate with the app and analysis. So this is the schematic diagrams. So this is the PCB layout. So in the slipper itself, we are embedding the PCB. The PCB will be your shoe pad like that. Okay, so that is the thing. So this is the actual visualization of the prototype, what we have made over there. So there is a one power cable and the one buzzer alert for the local signals. So it is an haptic audio signal, and one RISC-V processor that is completely indigenous, developed by IIT Madras Shakti SOC. So there is one I2C display, and then this is the sole, and behind the sole there are the FSRs. Okay, these are the sensors that can sense the pressure. So this is the thing where we have connected web. We have developed one app and the web interface. So where you can see that in the picture one, this is the thing regarding the sensor connection and the calibration. So we have offering the 2 modes of calibration. One is the automated calibration and the one is the manual calibration also. And this is the guide towards the next steps and the following thing. Though the second picture shows that it is the dashboard where you can have the number of the steps and the average pressure until the now and what we need to do. And the thing 3, it is the personal information and the regarding the device information. Regarding the 4th picture, we have the A and ML analysis. Yeah. So AML analysis, we are sensing the pressure patterns over there, and there are some techniques and the pressure patterns which need to be imposed over the patients, existing patients, to cure the disease. So this is not the device for existing, it is the device for also to get not to get over the disease. So these are the experimental results. We have done the experimental test on our university only. So with the board permissions, we have tested on 20 users, and these are the 2 user results. So the novelty is, we are using the open source RISC-V, and which is completely made over in India. And we are using the HML and adaptive calibrations, which is need to be imposed over. We need to use this device for multiple users, right? That we are using the adaptive calibrations. And the main thing is RTOS. So I am specializing, doing the specialization in RTOS. So this is where the actual novelty came for. It is completely run over the indigenous RTOS developed by us. And there is an app support and user application. So coming to the problem, we are going to solve the amputations in before, and we are going to reduce the diseases patients over the time, and we need to prevent the diabetic feet ulcers, and we need to make the lead curable, already existing persons. So finally, this is the problem what we are going to solve. So coming to the market analysis, since every technology needs an end product to market, so this is the service what can an engineer can be offered to the society. So since they have a greater market for the diabetes, so there are these are the things collected from the existing sources like Times Group magazine and the Global Market Insights. So coming to that, there is a greater potential regarding the diabetic devices or any medical devices. It's gradually growing up. So coming to the market analysis, there is expected growth of 11.1 CAGR percentage, and total addressable market around the $781 million US, and total addressable market around $57 million US, and the SOM about service obtainable market where we can obtain it in India is around $1.2 million. So these are the not figures made by me. These are the things I have collected regarding the diabetes things from the WHO reports, ICMR reports, and the Time Group magazines itself. So this is the competitive landscape where every technology has a lead competitor, right? So we are also have the competitors like Modcon Science, which is a German-based company, Siren Care, Sensoria Health, and Tactiles. So these are the leading companies which are working on this type of devices itself. So coming to the budget analysis, these figures are not the exact one. So every startup needs some grace amount, right? So coming to the percentages, we are decided to spend our 1/4 of money in R&D and 50th percentage of money on talent acquisition, where you can also have the same figures around for 20 lakhs. So this, and for infrastructure and all those things, we need to spend only 25%. Since it is a medical device, we need to analyze the more, and if we want to bring it up, it has the deeper research and the more accuracy, right? Since that's why we are focused on talent acquisition and research and analysis part. So coming to the research mobilization plan, so we are coming to the category-wise some talent. We are spending around 0 to 2 months. So where we are getting, there we have mentioned acquisition strategy, industrial hiring, and competitive compensation, right? So regarding the partnerships, we are going to be manufacturing partners. Since the main part is the crucial regarding the hardware design. So we need to bring the flexible PCB where it can be look like a shoe pad. So that is the thing, we need to partner with the manufacturing companies also. So coming to the technical resources, we are using the open source RISC-V and the BLE modules that are already existing. So coming to IP and legal for research and some analysis we need to do regarding the RTOS parts and all those things. So that way we need some EDA tools. Okay, so that is the thing. Coming to the summary regarding, it is an innovation regarding the RISC-V processor and integrating the FSR sensors to cure a certain disease over there. And coming to the performance, we have already tested over that, and it delivers 20 millisecond and average 95% accuracy regarding the sensing part of the pressure and the pressure get from the slipper. So this is the where next in a few minutes I have the research publication regarding we are reducing that 20 millisecond alerts to the 5 microseconds also. So coming to the impact, it is a low resource and high need setting. So coming to the scalability, it integrated with the network and everything. So we are going to implement, already we have implemented the generative AI in the web analysis. So we are taking the values from the patients itself. We are collecting our own raw data to train our models. So where we can implement the machine learning so to get the values better. So these are the references where we have taken this project. So finally, thank you, and I need some suggestions and any questionnaire from the jury. Yeah.
So I have one question.
Yeah.
You mentioned about the latency.
Yeah.
You mentioned about the latency on one of the slides.
Yes, sir.
If I may ask, what is the frequency at which you are running the system?
Actually, we are running at the frequency of 1000 Hz. We are taking the samples, and that's we are using 2 buffers concept to reduce the latency also. So that means
what frequency you mentioned? 1000?
1000 Hz.
Hertz.
Hertz. Yeah, Hertz.
So you're
that means 1 kilohertz.
1 kilohertz.
Yeah.
Okay. But you mentioned about RTOS, right?
Yeah.
Real-time operating system. So I presume that's a free RTOS.
Yeah. So
open source. My suggestion in that case is like with the commercially available, you can say low-cost embedded solutions like Arduino or Raspberry Pi, they are already working at few megahertz.
Yeah.
So on that sense, it might lose out a bit. That's my suggestion.
Yeah. So, okay, sir.
Because for a real-time system, only latency is the key, not performance.
Yeah.
So if you go higher in frequency, you don't gain anything. But per se, in my opinion, on the competition analysis part, if you are running at 1000 hertz, I am quite sure that on the latency benchmark, this product could be defeated against the competition.
Yeah. So that is the one thing. The latency, actually, I have mentioned this, the sampling the taken. So 1 second, at 1 second, we are taking the 1000 samples. So for the better thing. Yeah.
Okay. I think, have you understood the question?
Yeah, I have understood.
Just respond to that.
Okay.
And my observation is as follows. I appreciate you're using the Shakti processor.
Yeah.
So that's good, indigenous, thing to be something we can always leverage on. My only concern is coming from the validation. How does your data helps with diabetes? That part is like, something, do you have any medical doctor on board as part of your team?
So actually, in initial prototype tape, we are combined with our university doctors only. So later, when we are growing up, we need to go over for medical validation. So as of now, we are taking the care, the tests under our university board only. So there is a university medical, so we are working under them only. So no exact medication from any standard boards. So we are working under our university doctors itself.
Monish, I also have a question. We already have products which are made for this diabetic foot ulcer based on piezoelectric sensors because they're giving a better sensitivity. So they're already working. They give the complete foot map, complete gradient of your pressure we have. So how do you differentiate from that? What advantage you think you are offering by using FSRs over piezo?
So piezo is a different concept now. Piezo has some issues regarding that piezo can generate the energy. So FSS can sense the energy. So the piezo may have some losses over there, and we can dominate that one with the FSS, right?
Cost might also be another good factor.
Yeah, FSS cost is also very low, ma'am. So than the piezo. Yeah, sir.
One more question. So are you using piezo, or which sensor you are using? And how you are identifying the location of that sensor?
Actually, you have seen here. So we have, so there are certain pressure parts of the leg. So we have placing the sensors over that area, and individually they can be easily captured. So which signal from the sensor we are getting, we can identify that signal. So there is no issue with the region of capture. So the sensor directly attached to the microcontroller itself. Suppose if the sensor 1 is activated, it is in the frontal part, then the pressure is applied on the frontal region of the leg. So that's like we are calculating.
So do you have any comparison table, like this much amount of pressure represent something, some medical disease, right? Some relation you have with you?
Actually, I am not presented here. We have wrote one research publication over there where we can have the complete detailed analysis regarding that. If you are free, I will share that. Yeah. So in the next few minutes, I have one research publication. Yeah.
Firstly, of course, regarding the correlation between your product and the diabetes, that was one thing which sir also asked. Second, just an input from your from my side on the commercial side where you've asked for your funds and everything. You've missed out on a very important part, that is the certification and validation, because it's a medical product.
Yeah.
So that is something which I think you should consider on the cost.
Yes, sir. Actually, we are working on Indian electronic standards, IEC standards for medical. Since it is completely related to PCB manufacturing, so we need to take care about that also. So since it is a basic prototype level, it just at a lab level prototype, so we not bother about that standards. So definitely when it coming to the product, we will ensure it is a standardized product over there. So thank you. Thank you the VDAT Circuitpreneur team for this wonderful opportunity. Thank you, ma'am.
So our next team is Numero Technologies, led by Dr. Srinivas Daulatabad.
Dear faculty members, fellows, and my dear friends, I am Srinivas Doltabad, and my friend Somansh are here to present Made in India Scalable IC for Secure Storage and Cryptographic Solutions. The work has been carried out under Numero Technologies, which is a startup at SINE under IIT Bombay, and the company is headed by Professor Udyan Ganguly. So our work is in the domain of security. So the security is needed for defense, aerospace, military, space applications, and so on. So this security is a very vast domain. So we cater specifically to OTP, that is one-time programmable memory, that is secure memory, and PUF, that is physically unclonable function. So that generates unique keys for stochastic process. So again, there are many people who are competing with us. So existing competition, they use high breakdown voltage and use complex circuit for that. And currently, India utilizes legacy nodes, and our competitors use PVT-based variation, which is good at lower nodes, but at legacy nodes, it don't provide very good performance. Further, we need all made in India things. So I would like to present our two patents. First, we have patented a specific recipe that allows us to make a MIM-based capacitor, which is heart of a anti-fuse OTP memory. So here we are able to come up with a 25 Armstrong capacitor, MIM capacitor, which breaks down at 3.3 volts. Our competitors have most of the time around a breakdown of 10 volts. That leads to high complicated circuits. Again, the second patent is generating a random number that is independent of technology node. So here we have come up with a parallel capacitors, two parallel capacitors, and the patent allows us to break only one of them, ideally making it 50% probability of getting a 0-1 or 1-0. So it gives us a very high quality random number. So the novelty is we are able to come up with a technology that can provide us random numbers even at legacy nodes like 10 micrometer, which is in our India's interest, where we are eager for low cost legacy technologies. Further, we are able to make a OTP capacitor which can break down at around 2.3 volts, enabling us to make a OTP memory working at only 3.3 volts. This is very critical because this enables us to eliminate these charge pumps which are vulnerable in space, and again they are prone to hackers and attackers. So third thing is physically unclonable functions. Physically unclonable functions, which here we are able to get the exact 50% Hamming distance, which means we are getting high quality random numbers. So problem that we are solving is we are able to obtain low voltage operation that enables us for space application and cost effective. The requirement, PUF requirement, like high quality randomness, we are able to obtain, and as the probability of 0 and 1 is exactly 50%, we eliminate post-processing, which is again very prone to hackers, and again in space application that complexity leads to further problems. Other thing is this is a CMOS compatible process, so low cost, low energy, and it has been completely made in India. That means from technology to chip manufacturing, everything is India. So we are not dependent on China, America, or any other people. So here is a very brief design. This is our unit cell for OTP, and our patented technology. This is our differential PUF. We have assembled it like array, and this array has been replicated multiple times. So we are demonstrating 64 kilobit of memory, and it can go up to megabytes also. Using this, we have also demonstrated another chip where this is the core that is providing data or the unique password, and then this encryptions and hashing allows us to generate some QR codes, which can help us to generate authentication online. So this is the prototyping. Here we can see our device. We have brought it here also. So this is working device, and the second plot shows the temperature performance. So we comply with all the military grade temperatures from -40° to 120° Celsius. Next plot shows the life. So this is the TDDB based analysis that shows that the life of this memory is more than hundreds of years. And these are digraphs, and these are all the test results, which shows excellent memory performance. So I would like to call my friend Somansh Raj for taking it further. Thank you.
Thank you, Srinivas, and thank you, the jury members, for being here. So I'll present the next half of the slide. So basically, I'll talk about the market opportunity which we have right now. So basically, we, as a startup from IIT Bombay, we are focusing in 3 different verticals. One is strategic, one is government IDs, and one is commercial. For strategic, we are already partnering with DRDO for secure dongles, which basically acts as a key for enabling any external software or any technology. This can be also be used for trimming coefficient, which is basically if you have DAC or ADC, it can mitigate the PVT, which is basically issues during the fabrication process. It can also do that internally. You don't have to do it in external circuitry. Third thing is, it is red hard memory, which is a radiation hardness. So already ISRO has been a MOU with us for providing the secure same memory for the security applications and for the space applications. Third thing is driving license, because since this is OTP memory, it can also be used for driving license, government ID, passports, and everything there. And the third is the commercial angle. So this can be used for IoT, secure boot, secure storage, and root of trust. So it can be used with any laptops for TPM, for trust, where the trust requires. You can also be using for that. So our analysis is that by 2030, this market is supposed to grow at $60 billion for this commercial angle. And this is where we want to pitch in our security from now. And being as an indigenous and the first from India, we are proud that we are already way ahead in terms of our area and in terms of reach with the government and the private partners. So other players which offer the competition is Synopsys, eMemory, Kilopass, and Puff Security for different applications. And what we offer is low cost, since it is indigenous. So for example, there is $100,000 which the IP which is given by the Synopsys, and we can be using for space and defense applications. So this is so right now where we are is AMD has partnered with us. They have also given us the $100,000 CSR fund, and we have patent files. It is silicon proven, and it is TRL line. TRL line is commercially we can go to the market. And by 2027, we are expected to go for beta release, which is 1 megabyte of memory, which is fully, completely commercially given to the people for use. And why we require typically about $3 million of funds. That is what we expect. And because it is very heavily compatible, we need to pay to the fabrications. The manpower is huge, and right now, being the semiconductor market, everyone wants large sum of money. And we have a team of large people, all are poached by Micron and different people. So I'll just summarize it. Technical, what my friend said, that we've already demonstrated 64 kilobit of memory, and we have the patents with the company, and we want to commercialize into the semiconductor, the space, defense, and drone domains. And that's what we want to target. Thank you so much. Thank you. Yeah. Sorry, jury members, please, if you have any questions. Yeah, please. We have raised $100,000 from AMD. It's a CSR fund. Yeah. No, we have already a discussion with the Chipex company from Bangalore, but we haven't discussed any. That's what we expect, yeah, for next 3 years. We already, yes, sir. So we didn't got any funding as of yet. But yeah, yeah, yeah. That's a discussion between the founders and them. So if you're not the founders, we are working as a member of technical staff. Yeah. Yeah. No. It's a professor.
Udan Ganguly is the founder.
Yeah. Yeah. Sorry.
I have one question. That is regarding the memory, radiation-hardened memory.
Sure, sure.
So, how exactly you are qualifying your memory as a radiation-hardened? I mean, the TMR or some lead material that you are using. And second is, how you are going to qualify it? What is the test approach that you are planning to have to qualify it for the radiation environment, and for which particular orbit? I mean, LEO, GEO, sun synchronous, which orbit you are targeting?
Yeah. Yeah. Please.
So currently, this radiation had. So currently, this is under process. One of our team member is in touch with ISRO, URSC, and we are creating the test cases and the boards for all these things. And we are currently in the process of making it Red tested. So theoretically, it should be radiation. It should not be having any issue with radiation.
Any method you have identified how you are going to?
We are currently in the process. Means one of our team member. We are having meetings. We are making one, their equipments are there. So we are in touch with them, where our chip will be going in their system, and they will be throwing some radiation, and we will be doing all those tests. So currently it is under the.
So I want to answer. So we have already partnered with the IT Kharagpur. There is a Professor Deep Mukhopadhyay. He works in the radiation hardness. So they have all the machines. And we are also partnered with URSC. So like he said that, we have a beam where we can target on the IC itself. And
yes, cobalt is there. You can target, you can utilize, you can test it with the cobalt 16 source.
Yeah.
But my question is what methodology you are using
to
make it red hard, right? There are multiple methodologies are there.
Yeah.
So have you identified any particular methodology?
No. So what I understand is that we are trying to do the radiation hardness with the gamma, with the alpha and beta particles. That's what we are into. So we are still in the process of doing this. That's what the money is for, we are asking.
Okay.
Yeah.
Because it is prone to radiation. It may cause LET, SEUs, multiple type of the latchups will be there. And it is more prone to the protons.
Okay, yeah.
Not alpha, gamma. It is more prone to the protons.
Sure. Thank you for the question.
So thank you for a very inspiring presentation. Just one follow-up question. What is the implication of quantum algorithms in your kind of setup? It's a hardware encryption, right? Hardware-based crypto.
It is not exactly crypto. It is basically a random number generator that will be used in further cryptography. So it gives a very high quality random number.
Got it. Yeah. My only question, we keep on hearing these days that the quantum algorithms are able to crack this kind of encryptions. So is there any scenarios you have thought about?
So basically, whenever this encryption cracking is happening, so basically they are able to model the source of randomness. So here, the source of randomness is basically coming from a stochastic process of lightning inside the silicon oxide, which is around 25 angstrom. So as far as now, we are pretty much sure that this ANN should not be able to identify what is going inside this small medium. So if AI is able to decode it, then we can do anything. But as of now, we know, we are it won't be able.
But that's a good question. We can also take up as a follow-up and think about this in a different manner. Thank you so much. Thank you so much.
Thank you. It was very good. Reaching TRL9 is really a tough job and really inspiring for all others.
Yeah. Thank you. Thank you all. Thank you. Thank you, team. Yeah.
So our next team is Team Auraflow, led by Angad Singh. Angad, you would be given 10 minutes.
All right.
Meet
it often ends.
Meet Joseph. He wants to lose weight.
Come on, you can do it.
But he has never exercised before.
Ouch, my knee.
Do you know, approximately 300 million people exercise daily. 4 million join them every year, and lack of guidance results in injuries to 500 people daily.
Joseph and 500 others every single day. That's how their story ends, in pain, in frustration, and in fear of trying again. This is not a niche problem, this is a fundamental gap between human motivation and safe exercising. Current solutions are failing them, like YouTube videos, they do not provide real-time feedback, trainer sessions are not always feasible, and workout apps are just glorified timers and workout libraries. That's precisely why we decided to create AuraFlow, so that we can have a different ending for Joseph and 500 others. Just imagine you have a companion with you. Throughout your entire session, throughout your fitness journey, it tells you in real time whether a posture is correct or not. It gives you recommendation according to your body physique. And also, in the end of the session, every session you get a health report. In that, you will get to know about what you did right, what you did wrong, and how you can rectify it. AuraFlow mat is consisted of 3 main components: camera, pressure sensor, and LED lights. Camera measures body angles. Pressure sensor measures how much pressure you are applying and whether it is above the safe limit or not. And LED lights that guides you and tells you where you have to place your limbs according to the exercise you have chosen. So how does it actually work? Sensors collect data. In this case, they are from camera and from pressure sensor. AI analyzes the posture, and there's a user feedback loop and a recommendation system. In the end, you get the report after each session. So this is AuraFlow's technical framework. As you can see, this is the control unit. In that we have CPU for Raspberry Pi, which is connected to ST microcontroller, which further is connected to a Wi-Fi module. Wi-Fi module is there so that we can have progress share via Bluetooth. And the Raspberry Pi is connected with the voice recognition model, AI model, speaker, camera. In this case, this will be a Logitech camera. So camera is there so that it can get feed from the person who is exercising, and then it runs through and get processed through our AI models, and the output is delivered through speaker or a screen which is attached. Voice recognition model is there so that whenever the user says something, for example, he said that I am having a back pain today, so can you recommend me some exercises? So we use whisper.cpp in this, and it converts speech to text, and from the text we use some keywords, like back pain is a keyword. So it goes through our AI model, and through your own physique, it tells you and recommends you different exercises. ST microcontroller is connected with the sensors embedded in mat. In mat, there are LED lights and piezoelectric sensors. So all the data gets shared with ST microcontroller and then to Raspberry Pi. And this all happens in the edge device. So all the processing happens on device only, nothing is shared, and your privacy is granted. Now let's look at our AI approach. We use different AI models which get data from visual data from camera and from pressure sensor we process it for 20 plus workout poses. We use sensor fusion. So basically we combine data from pressure sensor and camera so that we can accurately decide what is a posture. We use optimized deployment. So we use 8-bit quantization and TensorFlow Lite framework for fast processing. We use MoveNet, which has 17 landmarks, along with threshold alerts and transfer learning. And this all happens in real time. So this is my friend Brahmjit. He is part of our AI team. So as you can see, there are some green lines and red lines in here, right? So whenever he is doing bicep curl, so when the arm is between the threshold period, threshold degree, which in this case it's 50 to 150 degree, then only on the left hand side, as you can see, the counter goes up when it comes under the threshold degree. In this case, this is the recommendation system, also developed by our team. So she has written, I am having back pain today. And the AI analyzes it and gives you the recommendation along with a YouTube video as well for more guidance, so that the user can see that how to do that particular exercise. Similar in the case of push-ups as well, when a particular threshold is achieved, then only the counter will go up. And our patent is published, and we are completed with TRL 3 and 4, and we need your support for creating an MVP and making Auraflow market ready. We have analyzed market audience to be tech-savvy fitness enthusiasts who are looking for smart data-driven workout tools. And the total addressable market is set to reach at $1.19 billion by 2030 with a growth rate of 8.3%, which indicates strong demand for Auraflow. We have analyzed 3 competitors, which are Prism Fitness, Yogify, and Wise Life. While the competitors focus on one piece of the problem, we want to focus on the complete puzzle and be with the user throughout his journey and help them. This is our BMC. This is our team. Angad Singh is the CEO, Priyam Ganguly is co-founder, and I am Bhavishya Singla, Chief Branding Officer. You can contact us through our email, and this is our website, which is also developed by our web development team. Let me quickly show you that as well. So as you can see in here, in future we want to focus on a larger market. So we have divided Auraflow into 3 different products, Auraflow 1.0, 2.0, 3.0, with different features and different price range as well. We are still developing, so that's why we have not written on the website. And we have a chatbot here as well, so it is still under development. But if we write about Auraflow, if we say Auraflow in here, it will tell us about what Auraflow is. Like in this case, it has written, Auraflow is a smart yoga and fitness mat that uses AI pressure sensor and camera-based motion tracking to guide posture, give real-time feedback, and provide personalized yoga and fitness routine through a companion app. And that is all. Thank you so much. And if you have any questions.
In the prototype, in the slide you had mentioned, you are using Arduino/STM32.
Sir, we will, because of the price, we want to start with Arduino first, so that we can have a proof of concept. That's why we have added Arduino in that.
So right now the prototype is based on Arduino. That's what.
Right now we have made web-based AI models only.
Okay.
MAT is not yet been made, but all the patent and that has been granted.
The reason I asked this question again was a similar thing that I asked to the other team that they were presenting. In your case, because you need a real-time feedback.
Yes.
Because the time, for example, the demo that you showed, the person while he's exercising, the time it takes for the feedback loop to run and send the data to the speaker or to the text. I think similar feedback I had shared in the review. It will be a matter of, I think what is critical for you is to benchmark. First benchmark, before
Yes.
even starting the development, how much of the feedback time you need. For example, I can share from a motor control point of view. So ultimately, you are doing a control loop, right?
Yes.
So you do some exercise in this case. For example, you are doing a motor control. So the motor is running. So you have to do the complete field-oriented control in a particular cycle. So what is the minimum time that is required for the injury to be prevented during the exercise?
Got it.
Is need to be benchmarked. So for example, it comes out to be X milliseconds. So from that calculation, you have to derive the architecture of your device in the sense what kind of CPU you will use, maybe STM32 cannot be the good fit. You need a better real-time core.
Yes.
In terms of which has a better interrupt latency, because sensor is sending the data.
Yes.
So you have to service the interrupt in a particular amount of time. So so idea-wise, I mean, this is just my thing. It's brilliant. It's very good. The only thing you need to do is that homework of doing the benchmarking on how do you architect the device.
Definitely, sir.
So
we
software-wise, everything is okay. The only thing is when it comes to implementation, because if it is sending in 2.3 milliseconds and my injury happens in 2 microseconds, so nobody will buy it.
Yes,
right?
definitely. We will look into it, and thank you so much.
I have one question that is regarding the position. Again, the same question. I mean, how are you identifying the position of the piezo buzzer? I mean, piezo plate. How are you going to calibrate that piezo plate for the different users? I mean, different users are having the different weights.
So first of all, we have our own data set, custom trained with the students, our university students as of right now. And what we are doing is we will take input first of their height, of their weight, and from that we have our own AI model that calibrates that. And there is LED lights on the border as well, so it will tell you exactly where you have to place your hand and where you have to place your feet exactly.
So how you are going to, that data you are going to take and you are going to do the curve fitting of that. I mean, you need to do the reverse engineering, right?
Yes.
You have to take some data and then depending upon the from pressure to electricity generated, electric charge generation, you need to do some curve fitting. I mean, that you need to take care, I guess.
Okay. Thank you. Right now, as I have shared that we have divided into different parts, right? Oraflow 1.0, 2.0, 3.0. Though we are still developing, so we have an estimate cost that Oraflow 1.0 will have around 4,000. In that we have LED lights only, so it will tell you where exactly you have to place your hands and feet. There will be no pressure sensors and no camera. In 2.0, we will have a pressure sensor inbuilt, so it will be around 10,000. And for 3.0, we will have camera as well and a vision board in the screen as well. So it will be around 15,000. And the competitor pricing is relatively same, but we are providing much more than that. Yes. Thank you so much. Thank you.
Just a minute. So before we move ahead with the next presentation, I would like to thank Mr. Pradeep Sikka sir, and I request Professor Goel to please facilitate him with a small token of gratitude from our side for being part of our event. Actually, he has to leave for Noida, so his train is scheduled. So please I request you to please join on the stage. Small token of gratitude.
Thank you, Judy.
Good evening, everyone. I am Keyur Mahant, and today I am going to. Should I install or how it is? Okay. So today I am going to represent on integrated thermal imaging system for surveillance as well as SFCW based radar system for landmine detection. So it is not moving. Okay. From there I am. Okay. Yes. Okay. Thank you. So this is the agenda of the presentation. I will start with the techniques for the landmine detection, then the comparative analysis of those techniques. Then I will go for the configuration that I am proposing. Then the fourth one is the thermal imaging system and the camera electronics that I had developed, and then the summary. So basically, I'm not going much details in the theoretical portion, but basically there are various techniques for the detection of the landmine. The first one is the physical or the chemical detection methods. In that we are having the metal detectors as well as VPDs, EVP for detecting the landmines. The second one is the radar-based techniques, where we are having the ground penetrating radars, SFCW radars, FMCW radars, and EMI technologies for detecting the landmines. The third one is optical-based methods, where we are having the infrared, ultrasound, and LIDAR-based mechanism for detection of the landmines. And the fourth one is biological or the biosensor-based mechanisms for detecting the landmines, that is having the trained animals we will be having for detecting those mines. So the comparative analysis I have kept here. So these all methods we are having, and in those all methods, they are shallow, or we can detect the landmines if it is on the surface. If it is below the surface, if it is deep inside there, then we are having only two methods which is more effective, that is a radar system, I mean a RF-based radar system or ground penetrating radars. And that landmines are of basically four types, that anti-personals, anti-tank, bounding mines, and blast mines. Right, so basically we are having those anti-personals are targeting the peoples, those who are walking, and there is a chance, there is a low pressure sensors would be there, then it will blast. Then anti-tank would be of higher pressure. It means if it is more than 200 or 400 kilograms of weight, then it will work. So basically this main two types of the landmine are there. If you want to identify those landmines, then the frequency range would be from 0.5 megahertz, I mean 0.5 gigahertz to 6 gigahertz. So if you will be having a system which is ranging from 0.5 gigahertz to 6 gigahertz, then we will be able to identify any landmine which is made up of metal materials, plastic materials, or any type of the landmines. So that is the basic idea, and that is what my objective is. Right. So I am proposing a SFCW-based radar system which is sweeping the frequency range from 500 megahertz to 6 gigahertz, and which will be able to identify the landmines which is made up of plastic, some part of the plastics, or metal. Right. Or it can be a personal landmine, or it can be a tank mine. Right. That can be identified. So while having this 500 megahertz to 6 gigahertz of SFC radar system, I will be able to go deep inside up to 5 meters. From 0.5 meters to 5 meters, I can able to detect the landmines with the different material characteristics. Right. So this is the proposed systems where I will be having the VCO, and that VCO would be controlled by the FPGA. So I will be having the different steps. I will be sweeping the frequency from 500 megahertz to 6 gigahertz. Then I will be transmitting those frequencies through some antenna, and I will be measuring the reflections of that. Then I will be trying to identify the objects. Right, because I will be transmitting the different frequency in the steps. Right, so this is one of the systems that I had developed for some other applications, that is 26 to 36 gigahertz for some atomic energy applications. There you can see it is swept from 13 to 18 gigahertz, and then I have doubled it, and it is sweeping from 26 to 36 gigahertz. And some horn antenna I have utilized for that reflectometry applications. And for testing those, what I did is I have utilized optical plate, so I can minutely change the horizontal position of that plate in microns even. And I have tested it, and it is working well. This is the whole reflectometry system. which is having the VCO, FPGA, LNA, and transmitter receiver as well. These are the reflections that I have measured, transmitted and received signals. So for that I had done two-way measurements I have done. One is I have kept the frequency constant and I have varied the distance. In the second, I have kept the distance, I have kept the plate constant and I have varied the frequency. So these are some measurements I had done. So this is basically the measurement results that I had. So that is the one system which will enable us to find the landmines. And the second is thermal imaging surveillance system. So basically we are having there is an electromagnetic spectrum. In the 400 to 700 nanometers, we are having the visible range and we are identifying the different objects. So that is basically we are identifying the spatial signature of that particular image, like a leaf having a pigment, chlorophyll A and B, right? So that is why it is identifying, it is reflecting red and yellow light, red and blue light. So that is why, and it will reflect, it will absorb the red and blue lights, but it will reflect the green lights. That is why it seems like a green, right? So similarly, if you want to go for the thermal, so basically each elements are having their spectral signature. Similarly, we can go for the thermal imaging as well. We are having the human body. Human body emits some IR emissions, and that IR emissions, if it is a cooled one, then it is a long wave IR. If it is a hotter body, then it is a short wave IR emissions would be there. So we will having that thermal map of those reflections, so which can build a thermal image, and that thermal image could be helped in the surveillance as well. Right. So these are the comparison I have made. So for the different sensors, different camera electronics, I can go for LWIR, I can go for mid as well, and I can go for short wave as well. But what data shows is for mid wave IR is the best one. I can go and identify the objects. So this is the proposed block diagram where I will be having the detectors along with the optics, and that data would be captured by the FPGA and process, and then it could be shared to the computer. So these are some of the camera electronics that I have utilized. This is for the space applications, where it is CMV 4000 is there, along with some camera, optics is also there. So these are the camera electronics that I have developed. So the point here is, final takeaway is, we can have one integrated system which can be mounted on some drone or some rover, or combine them. What we can have is, we can have the landmine detection as well, which is a very wide range. Whereas in the commercially available landmine detections are very short range. It can only identify anti-personnel or anti-tank, right? But here we are going for. Sir, what I did is, I have developed those systems, but that is for the different applications. Whatever I did here, that is for, this is the setup. What I had is, this is for plate detection, metal detections I have done, and that is where you can see here, I have varied the distance. I am able to get this data.
Air, right? But this is still air. It is not.
That is in the air, yes. And this is also for the different application. Okay. But my idea is, we can combine those two things, and we can have the third one, which is can be utilized for the military applications.
Yeah. Thank you very much for a very good,
thank you,
challenging work you're doing. Thank you.
Thank you. Any questions? Sure, okay. Thank you.
The next team is Jatayu, led by Astik Thakral.
Hello. Okay, so good evening, everyone. Thank you for being here and listening to me. So I am representing Team Jatayu, and our project focuses basically on indigenous flight controller. So our primary product is a flight controller that is completely designed in India. Now, I want all of you to close your eyes for a second and imagine the Indian sky above us filled with Indian drones, with all the components manufactured within our nation and the technology itself. Right now, the scenario is that most of the flight controllers that we use here are either fly sky, that includes a lot of imported products, and with a lot of tariffs coming in the way, the product supply is definitely going to be attacked by that thing. So we have designed our own flight controller. So it basically uses the Mindgrove secure IoT microcontroller developed by IIT Madras, and the transmitter and receiver used by us is also developed by another startup called AgniForge. Basically, we are integrating all these things into a one single package that helps us to fly a drone. So coming on to the next part, we even use the sensors that are used by us are completely designed in India. The GPS is Navic, that is also indigenous. So this automatically eliminates a huge dependency on Chinese markets. So my aim is to make all the products in India so that even our Indian suppliers can be benefited from this. And the good thing is that when we use such products, we are basically reducing the cost of manufacturing. So if you see, I would like to skip on to the budget part first. Yeah. So if you come on to the package that is available commercially, so that combined package consisting of the flight controller and the transmitter and receiver combines totally cost of 16,500 approximately. And the entire cost, if a person even wants to make a project, goes up to 50,000 if he uses such big stock flight controller. But when we use our package, it drops down to 10,000, and the entire cost can be reduced to approximately 25 to 30,000 for an entire UAV. That's a huge reduction in the cost, about 20,000 rupees. So our aim is to make the products available to the Indian market, so that the more the products are available, we will be having higher profit margins compared to the commercially available. So we will be able to generate higher profits and capture a better market in the overall run. Coming on to the prototype version. So basically, I have explained you the microcontroller that we are using. It's a Mindgrove secure IoT. And this is the working model that we are currently working on. We are currently developing the code for this using the ESP32 module. But we aim to shift to this Mindgrove microcontroller in the future. Now, what I want from you is to fund our startup so that we can expand our horizon, so that we can jump into the Indian market, that are the microcontrollers that are made by Indian producers. Second, we aim to develop a kamikaze drone made from our own flight controller. So Indian Army is hugely searching for these kind of drones, because a lot of drones that are right now present in the Indian Army are either imported or they have a very less technological advancement compared to the foreign counterparts. So we basically aim to produce a kamikaze drone using our own flight controller and own transmitter receiver, so that we can even supply to the Indian Army and have a better market over there. So the market opportunities, as I mentioned, the kamikaze drones, and besides that, we even have we can even export them. So when the cost reduces, definitely people from other countries will also be buying from us. Sure. Yes, sir. So weight is actually dependent on the motors, basically. So that depends on the payload also. Like if you are using a very heavy duty battery, you can lift a larger payload on that. And basically right now we are using 1300 kV motors. So they are able to lift an average payload of 5 kgs. But if we modify the motors and if we modify the battery capacity also, that can increase the payload capacity up to 20 kgs.
एक आप डिजाइन में भी थोड़ा एरोडायनेमिकली जरूर बनाइए।
Sure,
मैंने
sir.
आपका जो मॉडल देखा है ना, तो वो अभी एरोडायनेमिक की शेप के अंदर नहीं है।
Okay.
So you have to work on it also.
Sure. Any other questions?
So you have used the Neo 6M module as a GPS module. So does it support NAVIC system?
I'm not using, I will be using NAVIC as a GPS module. It's an indigenous GPS transmitter receiver.
No, NAVIC is a indigenous GPS framework, you know.
Yeah.
But how can you say that Neo 6M support a NAVIC framework, but it support a NEMA?
No, I can use a Neo 6M also. We are currently prototyping it on Neo 6M only. That's commercially easily available. So,
okay. So are there commercially available GPS module that support NAVIC?
I didn't get your question. Can you repeat also?
I'm asking, in the market, there are any module available that support NAVIC?
Yeah, definitely. There is like the NAVIC GPS comes with a separate chip that is used to integrate it with the NAVIC and the microcontroller.
No,
you can now directly integrate it on a
Okay, thank you.
Sure.
Yeah, so I would like to clear out some things. First of all, NAVIC works on L5 band. So
Okay.
in GPS, there are different communication bands that are used by all over the world.
Yeah.
There are three main, L1, L2, L3, and L5. So NAVIC is a L5 based GPS, so that uses totally different megahertz frequency for communication.
Okay.
And the hardware that he was asking for is Quittle. The company name is Quittle, and it offers a NAVIC GPS. It costs around 700 something.
Yeah.
And it works. I've worked with it. So my question for you was that you have said the commercial flight controller costs around 15,000 with RC controllers, right?
Yeah.
But I can name you a flight controller and a RC that comes under 8,000. Both of these things have a range of around 2 kilometers. The flight controllers have all the basic sensors that you have accommodated. That includes IMU, directional heading, barometers. So I would like to know, first of all, what is the range of the radio you're using, or how much performance can we get off your flight controller? Next thing, if there is already these modules that come with these existing sensors, why would we purchase yours?
Okay, so coming on to the first question, you were saying that you found a like a package with the flight controller and the transmitter receiver. Yes, ma'am. No problem. Sure, no problem. Yeah. No problem.
Power Research Consulting, led by Dr. Rahul Gupta.
मेल अभी कर देते हैं व्हाट्सएप पे मेल पे मैम एक्चुअली पीडीएफ मांगता हूँ नहीं वो पीपीटी भेज देता ना मैम हम विदाउट पीपीटी देते हैं और नहीं सर बहुत डाटा प्लीज़ आप मत किया करो
पीडीएफ चल जाएगा तो वाला था पीडीएफ है तो सही पर वो पता नहीं चला इस पे चलती नहीं है
मैं आपको पीपीटी शेयर कर देता हूँ मैंने कॉपी निकाल ली थी अभी यही है मैम इसमें 102 है मेरा
तो नहीं चलती नहीं है तो रही चल तो रही
आ गया हाँ चल तो रही है
पता नहीं क्या
चल जाएगा मुझे. It will work for me. कोई इशू नहीं. वीडियो से चली थी आपकी ऑडियो से. अरे कोई नहीं, अपन करेंगे, टेंशन बैठ तो आराम से.
Good evening, all. Thank you for giving the opportunity to present our power research consulting. We actually started from the Maharaja Agrawal University and then started our journey towards the IIT Mandi. Now we are incubated at the IIT Mandi and the Catalyst. Basically, the power research consulting is a basic idea for provide the solutions for the economic as well as the energy management to the existing resources. We are working on the various domains like firstly, aquatic drones. Second is the energy management. Third is the biomedical fields. Basically, we started with from the Yukti competition of the project named the Varuna. We developed the aquatic drone for the Ministry of the Education, in which we stand first in the competition. Now details will be shared by my co-founder, Navneet Sharma.
Thank you, sir. So good evening to all. My name is Navneet, and I have my bachelor's in electrical and electronics engineering and master's in VLSI. Today I would like to represent my startup Power Research Consulting and the projects I've been doing there to all of you. So the core project that we are developing under our company is Varuna. It's an autonomous underwater vehicle to map, measure, and monitor water quality levels across a very large water body. So that may be lake, river, reservoirs of the dams, etc. The problem statement was raised by Ministry of Water Resources during SIH 2018 hardware edition, and we were the finalist for the same. As the solution was not given as per ministry's requirement, we thought of developing the same under our startup and working since 2022 to develop the same. First of all, I would like to give you the intro to my team. So as you can see, me and my founder, sure sir. I'm showing some of the business viability that we have researched till now. So there you can see the TAM is around 3.6 billion as of 2021 perspective. SOM is 360, and similarly SAM is 360 million, and SOM is 36 million. We do have multiple revenue streams for our drone, for our future projects. That includes hardware package selling, software subscription, and customized solution. We're also looking to provide service-based model so we can have a better grasp of our customer to how would they like to get our services. The impact and feasibility are great. As you can understand, it will help us monitor and track environmental pollutions all around water bodies. Secondarily, it comes with different sensors and technologies that include sonars and other detectors to map and monitor the bay area or the land that is normally underwater and you're not able to access this, so it would be able to do so. We have currently reached TRL 6, doing our environmental testing, proving our hardware is working. We have validation from Ministry of Education as well as Department of Science and Technology, having grants from them both. We have continuously winning multiple competitions throughout these years working on this. For the budgets, as you can see, we have grants from DST under Nidhi EIR. From Ministry of Education, we have under Yukti 2.0, and MAIC is the Maharaja Agrawal Incubation Cell. So that's our home incubation, which has been funding the project since 2022. So these are some of the budget outlines that I have created for the development for next phase of our hardware. So majority of the cost goes to the hardware things because it is very costly to procure equipment that works underwater or have that kind of ratings, and rest of it, as you can see, are for business development, IP, and miscellaneous personal overhead expenses. So this is the current prototype that we are working on. As you can see, I have brought one of the demos with me, and it had all the electronics and working systems in it. The systems that we have developed for our autonomous underwater vehicle includes all the custom hull and body. So the design is patented. Nothing like this exists beforehand. I have designed and fabricated all this via my hands. And there is specifically, we are getting
5 degrees of freedom with only 4 thrusters, and usually you have to add 1 more thruster to get the same exact results. So you'll need 6 thrusters to get 5 DUF normally, but we are getting 5 DUF with only 4 thrusters. Similarly, here is the microcontroller circuit that I have developed, first tested on a PC breadboard, and then developed the schematics and PCB fabricated the same. We are testing all our modules on modular level first. So as you can see here, we have a wireless communication module consisting of at least 4 different type of communication module, ranging from GSM, GPS, LTE module, RF 2.4 gigahertz, and another RF of 5.8 gigahertz, and a specific 433 megahertz emergency frequency in case something went wrong. And there are all these subsystems that are working together. So battery management system and load sharing is also there. All the things that we are developing electronically right now is on modular systems, so we can better test and iterate them. And once we have the final version, we'll have each and everything on our own PCB for the custom solution. And as I told you, we are developing each and everything by ourselves. So these are the thrusters that we have developed using iterative designing and simulations. We have 2 types of thrusters for now, the BLDC ones that using brushless DC motors, commercially easily available, and another one are the DC ones. And yeah, so that was the one of the testing videos that we had. And yeah, any Q&A? Thank you.
We are the first company. We are the first company to bag the position in the Singapore for the development of the nanogrids in India. So we have received the offer letter from the University of Singapore and the think tank to develop the AI-based nanogrid for the society of the India. Any questions?
Thank you. We are open for questions. Thank you.
So the final team is Team Yodha, led by Sambhav Mehta.
नहीं भाई मैंने उसमें डाली थी पेन ड्राइव में नहीं मैंने मेल नहीं करी एक बार मेल कर दोगे हाँ कर देता हूँ
बहुत सारे कनेक्शंस प्लीज जस्ट मी
So good evening, everyone. So I want to give a point over here that we all have been to colleges, and the same guilt and same boredom that we all have felt in the lectures is of the time when our professors take the attendance. It's such a waste of time of 10 and 20 minutes in which it is One point is that it is time inefficient. Plus, we all know how much proxies are there. So, I have come up with a solution that is of BLE-based attendance system. This system is here with a Bluetooth technology which only logs the attendance when the student is present with his device. Novelty of this solution is that it's a time-logged attendance. That means there will be a session of 30-40 minutes in which the student has to be present in the class. Also, it's proxy-proof. It is using SQLite, which is a really lightweight database system, which I'm using over here. And you have to only one-time set up on your device. For the prototyping, I have used ESP microcontroller, and the technology that I'm using is Bluetooth Low Energy. Database is SQLite. And for the portals, there will be one portal for the lecturer, and there will be the other portal for the students to be used, as we can see over here. Students portal and the professor's portal. The benefits that we have is that other systems for taking attendance are really time consuming, like if you see for the manual attendance, roll calling, they take a lot of time. Then the other is that mostly of the attendance are proxies. Then coming to the online modes too. Most of the online modes currently used are not tamper-proof. Most of them are like tampered, like QRs and these type of things. Here is the detailed design flow of what happens, but I will not explain it over here because without the video, it is of no use. Now, for the comparison, if we see over here, comparing it to the other methods of the taking attendance, if we see over here, other methods, most of them are not time efficient, they are not tamper resistant, but if you see for the Bluetooth Low Energy, it marks on all the parameters. If we talk about the budget of my prototype, it will not take more than 600 to 700 in making the prototype that I have. Market opportunity is a lot more than what we think. Because we can take the example of this VDAT conference itself, which is going on. In this conference too, the attendance was taken on paper, but it can be much more efficient if we would have been doing something, we have implemented any type of technology for that. Otherwise, we have so many colleges in which so much time is wasted using these type of manual systems, and it is just waste of time for that reason. Resource mobilization and testing of the prototype, for that I have thought of starting from the basic steps, like from small groups, firstly a group of 5. Then till now I have tested it on 10 to 20 people, and it is sufficiently working. Then afterwards we'll move to the 1 class, 2 classes, and tested it on 10 to 20 people, and it is sufficiently working. Then afterwards we'll move to the 1 class, 2 classes, and then we'll move forward like that. The summary and the plans that I have for forward is that of also inducing an app learn, so that he'll have a focus in the class as well as he'll mark the attendance too. Thank you as well, and I'll show you the video, which would really help. No, there's no video. I'll show you on the app. Thank you.
I will first request Dr. Anand Soni, please join us and accept us all with gratitude that we have.
Thank you one and all the innovators and presenters who were part of Circuit Panel. You came in with a lot of enthusiasm and a lot of effort. We kind of appreciate that. And we were, as judges here, we were really appreciating the ideas. As a forward connect to this, your efforts. So now that you have thought about your idea and you want to take it forward, IHFC, which is the Technology Innovation Hub of IIT Delhi in the domain of robotics, provides a funding opportunity to the tune of 5 lakhs, up to 5 lakhs. So I would encourage you to apply for this program, which is called as the READY program. I know some of the startups are already matured, so they have larger grants and funding. But anybody who is wanting to validate his idea, and the drone idea, the BLE attendance system idea, and all the other ideas where you feel that you want to take your idea from a concept to a prototype, you can take advantage of the READY program. Also, on behalf of IHFC, there are some keychains and some pens, so maybe they will be in your bags. And I once again congratulate you on behalf of the panel for an excellent effort here. Thank you also to Chitkara University team who are enabling the whole process. Thank you. Thank you. Thank you, Dr. Gaganpreet, to invite us. I know we came from some distance, but it is worth coming here. When we saw the innovations and when we saw your passion and enthusiasm. Thank you and thank you.
So it is the time in which you must be waiting all the participants. So first we start with the certificate of participation to all. Let's start with everybody. Hope the night of the website. The first participation certificate goes to Symposium.